Hi everyone, Assalamualaikum. In this video, we will continue with derivative of inverse trigonometric functions, right? Alright, we recall back what inside the first chapter, inverse trigonometric function, right? We done discuss the first topic and the second topic. Now we discuss the third topic, which is derivative of inverse trigonometric functions. Right? Right now, we continue with example 2 and the simple examples for derivative of inverse trigonometric function. Okay? Given y equals to inverse cos x over 2, differentiate with respect to x. Right? From the given question y equals to inverse cos x over 2, we can find dy over dx when we differentiate with respect to x, right? From inverse cos and x over 2, this is composite function. So we can draw outer circle and inner circle, right? Then we pass with two other circles, okay? And in between must multiplication operations. Okay. Right. To differentiate inverse cos, we can refer from the simplest formula, derivative of inverse cos single x equals to -1 over square root of 1 minus x squared. Right. So when we differentiate inverse cos x over 2, okay, we can replace here. Okay, if we differentiate inverse cos single x, the answer equals to -1 over square root of 1 minus x squared. So now our x equals to x over 2. Okay, so when we differentiate inverse cos x over 2, so we will get -1 from here, we copy from here, and then over, we copy from here, and then we have square root symbol, and then 1 from here, minus, and then we replace x equals to x over 2. And then we have squared here, right? Alright, after that, we differentiate x over 2. Okay, x over 2 means half x. Okay, when we differentiate 2x, let's say, we get 2. So when we differentiate half x, the answer equals to half. So we can put here, right? And after that, we can simplify. Okay? Square root of 1 minus x over 2 bracket squared. When we standardize the denominator, okay, we get 4 over 4. 4 over 4 means 1, and then minus x squared over 4 because 2 squared here, right? And after that, square root of 4 here, we can simplify. So we get 2 here. 2 here, no more square root because we simplify square root of 4. So we get 2 here, no more square root, right? So now we get -1 over square root of 4 minus x squared over 2. Okay, 2 no square root, right? And then times half. Okay, then we can simplify. After we divide -1 over fraction here, so we can move 2 here up to numerator here. So we get -1 over square root of 4 minus x squared times half. And after that, we can simplify 2 here. Okay, then the final answer equals to -1 over square root of 4 minus x squared. Right? And we can check the answer using symbollab.com. Okay? To differentiate inverse cos x over 2, we can use common d over dx. And then inverse cos means arch cos, and then x over 2 in bracket. And then after we press enter, we will get the final answer equals to negative 1 over square root of 4 minus x squared. Okay, so this is the final answer. This is the final answer when we solve manually, and this is the final answer when we solve using symbollab.com. Right? Alright, now look at example 3. Given y equals to inverse tangent e to the power of x cubed. Differentiate with respect to x, right? From the given question, y equals to inverse tangent e to the power of x cubed. When we differentiate y with respect to x, the symbol is dy over dx, and then equals to, and then the function inverse tangent e to the power of x cubed is composite function. Okay? Alright. This is actually 3 composite functions. Okay? So we can draw outer circle, and then inner circle, and innermost. Okay? And then we can pass with another 3 circles. Okay? And in between, must multiplication operations. Okay? And then to differentiate inverse tangent function, we can refer from the simplest formula, derivative of inverse tangent single x with respect to x. The formula equals to 1 over 1 plus x squared. So to differentiate inverse tangent e to the power of x cubed, the answer equals to 1, we copy from here, okay? And then over, we copy from here. And then 1, we copy from here. And then plus our x now, we replace by e to the power of x cubed. Okay. And then we have squared here. Okay. Alright, after that, we differentiate the second composite function. Okay. This is exponential function. So we can refer from the simplest formula under derivative of exponential function, which is derivative of e to the power of single x with respect to x. And the answer equals to e to the power of x. We get back. Okay. So when we differentiate e to the power of x cubed, we will get back e to the power of x cubed. Okay, we follow this formula. Okay, if we differentiate e to the power of x, we get back e to the power of x. So when we differentiate e to the power of x cubed, we will get back e to the power of x cubed. Right? And after that, we differentiate x cubed. Okay. Okay, derivative of x cubed, we can use power rule. So we move 3 to the front here. So we get 3x, and then we reduce 1 from power here. So we get 3x squared. Then we can put here, right? After that, we can simplify. So we have 3x squared, and then e to the power of x cubed over, okay, 1 over e. We simplify this, so we get e to the power of 2x cubed. How we get this? Okay, from here, from properties of indices, a to the power of m, bracket to the power of n. What should we do? We multiply the exponent. So means that when we simplify e to the power of x cubed and then bracket squared, now our m equals to x cubed and our n equals to 2. So what we do is we just multiply the exponent. So when we multiply x cubed and 2 here, okay, 2 times x cubed, so we will get 2x cubed. So when we simplify e to the power of x cubed bracket squared, the answer equals to e to the power of 2x cubed. That's why we get this. Alright? We can check the answer using symbollab.com. Okay? When we differentiate using symbollab.com, we need to use common d over dx. Okay? Alright. So inverse tangent here, we can write arch tangent. Okay? And then e and then to the power of x cubed. And after we press enter, the answer will display like this. Okay, 3e to the power of x and then x squared, and then e to the power of 2x cubed plus 1. Okay, this is equivalent to this answer, right? Alright, now we continue with example 4. Given y equals to inverse sec ln 3x squared, differentiate with respect to x. Okay, from the given question y equals to inverse sec ln 3x squared, when we differentiate y with respect to x, the symbol is dy over dx equals to, and then to differentiate inverse sec ln 3x squared, first we need to identify the operation between inverse sec ln and 3x squared. Right? This is composite function. Okay, so we can draw outer circle, inner circle, and innermost. Okay, because 3x squared inside ln function and ln 3x squared inside inverse sec function. Okay, this is not multiplication operation. And then to differentiate composite function, okay, we have 3 composite function here. So we can pass with the other 3 circles. Okay, and in between must multiplication operation. Okay, this is the way when we differentiate composite function. Okay, inverse sec ln 3x squared is not a multiplication function, but composite function. Okay, but when we differentiate composite function, in between must multiplication operation here. Okay. Alright, to differentiate function inverse sec, we can refer from the simplest formula. Okay, the simplest formula means inverse sec single x. Okay, when we differentiate inverse sec single x with respect to x, the formula equals to 1 over x square root of x squared minus 1. Okay. Alright, when we differentiate inverse sec any function, okay, so we can write 1 over, we copy from here, 1 over, and then x, okay, if we differentiate inverse sec x, we have x here and x here. So if we differentiate inverse sec ln 3x squared, we replace our x now equals to ln 3x squared. So we must put ln 3x squared here, we replace here, and then we replace here. Okay, we replace x here by ln 3x squared. Okay, and then we have square root symbol, and then we have squared here, and then minus, we copy from here, and then 1, we copy from here. Okay, we copy from the simplest formula for derivative of inverse sec single x, but we replace x now equals to ln 3x squared. Right? Alright, after that, we differentiate the second function, which is ln 3x squared. So to differentiate ln function, we can refer from the simplest formula. The simplest formula for ln is ln single x. When we differentiate ln single x, the answer equals to 1 over x. So from here, we just copy. So when we differentiate ln 3x squared, we have 1, we copy from here, and then over. If we have ln x, we must put x in denominator here. So if we have 3x squared, so we must put 3x squared in denominator here. Okay. Right, after that, we differentiate 3x squared. Okay, using power rule, we get the answer equals to 6x. Okay, when we differentiate 3x squared. Then we put 6x here. Okay. Right, after that, we need to simplify. Okay, x here and x squared here, we can simplify. So we get x here. Okay, this one no more x. Okay. Alright, and then 6 and 3, we can simplify. We get 2 here. Okay. Alright, after that, 2 times 1 equals to 2 over. And then from x here, we can put here. Okay. and then ln 3x squared, and then square root of ln 3x squared, bracket squared, and then minus 1. So this is the final answer. Okay. Alright, we can check the final answer using symbollab.com. Okay. When we differentiate using symbollab.com, we use common d over dx to differentiate. And to differentiate inverse sec, we must use common arc sec. And then in bracket, ln 3x squared in bracket. Okay. After we press enter, the answer gives 2 here over x here. And then ln squared 3x squared square root. Okay. And then square root of ln squared 3x squared minus 1. Okay. The answer looks like different, but actually they are equivalent. Okay. Why? Because ln 3x squared bracket squared actually equals to ln squared 3x squared. Okay. From this formula, if we have ln x bracket squared, we can write ln squared x, right? So if we have ln 3x squared bracket squared here, okay, we compare from here. So we can write ln squared 3x squared. Okay, we compare from here, right? And then, why we get ln 3x squared? Okay, from here, we can simplify squared and square root here. So after we simplify squared and square root here, we get ln 3x squared. Okay, so we have 2x, and then after we simplify ln 3x squared, and then this function are equal, okay, from this formula. Okay, square root of, and then we have minus here and then 1. Okay, so this is the final answer when we use algebraically method, when we solve manually, when we differentiate manually, and this is the final answer when we differentiate using symbollab.com. Okay, when we use common d over dx here. Okay, right, this is from here. Okay, after we simplify. Okay, this is the final answer. Coming up next, more examples for derivatives of inverse trigonometric functions. Okay, if you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.